Hello dear students, today we are going to discuss double integral, which is part of multiple integrals. In multiple integrals we solve double integrals, triple integrals, high order integrals. Okay, the concept of double integral is an extension of the concept of a definite integral to the case of two arguments, or you can say to two variables. Let a function fxy of the independent variable x and y be continuous inside some domain A and on its boundary. Divide the domain or this rectangle A into subdomains A1, A2, An of areas delta A1, delta A2, delta N. Let x or y or be some point in the rth subrectangle or subdomain. Now we form the sum as follows. Let f value of function at the point x1, y1 times delta A1 up to nth subrectangle. Now take the limit of this sum as n goes to infinity in such a way that the largest of the area delta r approaches to 0. If this limit exists, we say double integral exists, and it is denoted by this expression. This expression is read as double integral of function fxy over domain A. This double integral can also be expressed as a repeated integrals, like this way or this way. Here you can see that the inner integral limits are constant, outer limits are constant. Same is the case with this form. Okay, here they have integrated with respect to y first and then x. In this expression 2, they have integrated with respect to x first and then with respect to y. Okay, now here in this expression you can see that outer limits are constant as the previous case, but inner limits are function of x. If inner limits are function of x, then first we integrate with respect to y. If inner limits are function of y, then first we integrate with respect to x. Okay, as is written here. Okay, now we move to solve some examples to understand these ideas in a better way. Consider this example 1. So first we will move to the first part, which is integral 0 to a 0 to b function x square plus y square dx dy. All the four limits are constant, inner limit, outer limit both are constant, and the function is continuous. So using the repeated integral, you can integrate first with respect to x or y, or first with respect to y and then with respect to x. In either way you will get the same values. Okay, so first I am going to integrate with respect to x. So first write it. Okay, 0 to a, integrating with respect to x, we get plus y square times x, limit 0 to b dy. On substituting the limits, we get b cube upon 3 plus y square b dy. So now integrating, this is a one variable integral, you can solve it easily. So now on integrating we get b cube upon 3 times y plus y cube upon 3 times b 0 to a. This is nothing but a cube b cube a upon 3 plus a cube b upon 3. On simplifying you can write it a square plus b square upon 3. So what would happen if we integrate in a reverse order. Okay, let us see. Alternatively, 0 to a, 0 to b, function x square plus y square dy dx. Okay, so first we write it in this form: x square plus y square dy, and then with respect to x, 0 to a, we are going to integrate with respect to y, so we will treat x as a constant. Okay, so on integrating with respect to y, we get x square times y plus y cube upon 3, limits 0 to b dx. On substituting the limits, we get uh, x square times b plus b cube upon 3 dx. Again, this is a single variable integral, you can solve it easily. So x cube upon 3 times b plus b cube upon 3 times x, limits 0 to a. On substituting the limits, we get a cube b upon 3 plus b cube a upon 3. On simplifying, you can write it a square plus b square upon 3. So you can notice here that from on reversing the order, you are getting the same answer. Okay, so this is possible if the function is continuous inside the domain. Okay, but this is not true in general. Okay, now we move to part second of this example, which is 1 to 2, limit 0 to x, function 1 upon x square plus y square dx dy. Here you can notice that the integral limits are not constant. One of the integral limit is variable, it is a function of x. So since it is a function of x, so it is value of y, so we are going to integrate with respect to y first. Okay, 0 to x, 1 upon x square plus y square dy and dx. So if any of the integral limit is function of x, then first we will integrate with respect to y. If inner limits are function of y, then these are values of x, so first we will integrate with respect to x. But here in this example, since the limit is function of x, so it is a value of y, and if it is a value of y, so first we have to integrate with respect to y. Okay, since we are going to integrate with respect to y, so we will treat x as a constant. So the integral of 1 upon x square plus y square is nothing but 1 upon x tan inverse y upon x, limit 0 to x dx. On substituting the limits, we get 1 upon x tan inverse 1, and tan inverse 1 is nothing but pi by 4. So pi by 4 minus tan inverse 0. Tan inverse 0 is 0, so no need to write it. Again, it is a single variable integral, you can solve it easily. Pi by 4 times integration of 1 upon x is nothing but log x with limit 1 to 2. On putting the limits, we get log 2, since log 1 is 0. Now using these ideas, you can solve other questions. Okay, thank you.